All right, we're back. We're going to be on page 6. I said at the end of the last video that I wasn't going to check them on the video, but I would check them later. I did find I made a mistake. So it was on number 5, and I actually made kind of 2 mistakes. First of all, I forgot a 3 here. Not a fatal error. I don't think I ever would have noticed that if I wasn't like pouring through this trying to find the mistake that I made. The mistake I made, I didn't integrate basically. Like I sort of did. I multiplied by 1/6 to get 1/18th, but then I didn't increment the exponent. So this is the correct answer. So if you watched it, I don't know if you're not watching them consecutively, that's on you. But let's do some more stuff. So new problems, new page. What are we gonna do? Well, this is a classic, right? An odd power of cosine. So I'm gonna rewrite it as I don't really want to. So I don't know, like that maybe, and then cosine to the 4th. And then we're saving cosine of x dx because cosine's to the odd power. So we'll save this, change every other cosine into a sine using the identity. And then we'll do like a u substitution if we drop that set of parentheses there. 1 minus sine squared, and then squared, and then cosine x dx. Okay, so here we go. U is equal to sine of x. Du is therefore cosine of x dx, and we're like good to go. So this will be u to the 1/2 quantity 1 minus u squared squared du. So we're gonna get a lot of rational exponents, but that's not that bad. U to the 1/2 1 minus 2u squared plus u to the 4th du equals u to the 1/2 minus 2u to the 5/2 plus u to the 9/2 du. And here we go. So plus 1 times reciprocal. So 2/3 u to the 3. Oh, let's replace u with sine as we go through. Yeah. So 2/3 sine of x to the 3/2. Plus 1 times the reciprocal is going to be minus 4/7 sine of x to the 7/2. Plus 1 times the reciprocal, 2/11 sine to the 11/2 plus c. There we go. I think that's right. Okay. Next. So what are we doing here? We're going to save. We have an odd cosine, right? So we save it. It's all about the odd powers when you have sines and cosines. Sines and cosines are probably the most straightforward. And also, I would say probably the most common, so that's nice. All right, save it, convert it. I'm gonna try to skip multiple steps. This is a bad idea, but just because it's a bad idea doesn't mean it won't work, right? That's not really a great attitude, but u squared 1 minus u squared du. So we get u squared minus u to the 4th du, and then u is equal to sine, so let's integrate and substitute. 1/3 sine cubed minus 1/5 sine to the 5th, and then plus c. I think we did it. I don't know. Pretty. We made it straightforward. I don't know if it was straightforward or not. Tangent to the 4th. So I do not know what to do on that. Do I convert everything into, all right, so the derivative of tangent is secant squared. So I would need like at least one secant squared to deal with that. So do I do tangent squared? Yeah, I think, then how do I integrate tangent squared? Get 1 plus secant squared and go from, am I overcomplicating this? Maybe. I'm gonna make this tan squared and then 1 secant squared minus 1 and then dx. So I basically rewrote this as tangent squared times tangent squared. Okay, so then if I distribute, I can definitely integrate this part, and then I'll have tangent squared, and I can make that into 1 minus secant squared, and then I can integrate that. I I think. All right, so basically at this point I'm doing tan squared secant squared dx, and then I'm doing minus the integral of tan squared. So just kind of distributing. This is the thought process. I do them basically live. So here, this one's already perfect because this is the derivative of tangent. So it's going to be 1/3 tangent cubed of x minus. Now I'm thinking here I want to replace this with secant squared minus 1 dx, and then we can integrate that. So maybe I could have just done, I don't really know. Like my thought initially was to replace both of these with secant squared minus 1, but that would give me like secant to the 4th, and then I think I have to like reverse. So like, I don't know. I think I had to like go backwards maybe to make that work. Tangent, ew, some of them have parentheses and some of them don't. Plus the integral of 1, so plus x plus c. I think it might be that. That's a crazy antiderivative if that is in fact true. I'm gonna do the same thing in this video I did in the last one. I'm not checking them. I'll check them in between videos and then come back with more corrections in the event that that's necessary. All right, what do we do here? We save a sign. We'll have sine squared is sine to the 4th, and then sine of x dx. Okay, so if you, oh yeah. And then we convert all of our sine squareds. 1 minus cosine squared sine of x dx. Now I think it's better to make the substitution. So u is cosine, du is negative sine dx. So negative integral quantity 1 minus u squared du. Here we go, negative integral. So it's square the first, multiply them together times 2, square the second. I say that in my head every time. Actually, I say it out loud every time in the videos, but like that's how I always square things. So don't think that just because you semi know what you're doing, you stop using those sorts of things. I'm going to integrate and go back to cosine. So this is cosine minus 2/3 cosine cubed plus 1/5 cosine to the 5th plus c. There we go, I think. Yeah, so, okay, so I'm not going to check these here. I'll check them in between. Honestly, I don't even know. It takes so long to check these that it's kind of like, if you're pretty sure I'm wrong, just let me know. But I'll probably check them. I don't know. So I will see you in the next video where we're doing some more problems, shockingly. So I will see you there.